you want to be doctors? Okay, cool. So when I was in high school, I wanted to be a doctor too. How many of you want to be doctors because you want to help people? Cool. Okay. So I was that way for about a quarter until I realized that math and philosophy are way more fun than organic chemistry. Helping people is still good though. So I'm not only the computer science person for this event, I'm also the token math person. So I know you want to be a mathematician. Have you always known you wanted to be a mathematician? No? What happened? Was there a thing?
Yeah, I got into calculus.
Okay.
I decided because it's awesome.
Right? Calculus is magic, isn't it? It really is. Actually, there's some calculus at my day job. So I build robots. And I also work on websites. So I am a research assistant professor in computer science and engineering here at the university. So that means that I write code. I'm going to show you some videos of my code in action. I write papers about my code, and then I travel places and I talk about my code. So there's a lot of code in computer science, but that's really not what it's about. Computer science is the science of abstraction. It's about looking at a problem and figuring out a way to mechanically solve that problem with a step-by-step process. Now, it just so happens that right now, at the beginning of the 21st century, most of those mechanical processes are carried out by usually laptops, or desktop machines, or phones. But one of the really cool things about computer science is that it's not just about the hardware. It's not even just about the software. It's about understanding reality in a totally different way. So if math is telling us what is the truth, so 2 plus 2 is 4 almost all of the time. Computer science is about figuring out how to do things. So how do you add 2 plus 2? It turns out that that is an extraordinarily difficult problem, and one that unfortunately we don't have time to get into. So I started out studying math, and that was a lot of fun. I started out, and I also did a little bit of philosophy. And it turns out that there's a point in the early 20th century where math and philosophy merge and more or less become computer science. It happens in about the 30s or 40s when we ask, are there things that cannot be calculated? So how many of you think that there are things that cannot be calculated? Even if you had an infinite amount of time and an infinite amount of space. You guys are really sharp. So do you guys know that that's true, or do you think I'm just kind of leading you in the right direction? You know it's true. So what can't be calculated? We'll come back to that. So, what did you say?
Anything divided by 0.
True. Okay. But that doesn't make sense. Are there things that make sense that can't be calculated? It turns out there are. It turns out that it's actually impossible to write a program that will look at another computer program and tell you 100% of the time whether or not it's broken. Which is part of the reason that so many of our computer programs are terrible. But what did you say? Controversial statements. So what do you mean?
Like if I say I am lying.
I am lying. Okay.
It will tell the people lying.
Paradoxes. Yes. Yeah, so that's exactly right. And that's what they looked at, slightly more complicated, but that's the gist of what they showed back in the 30s. Is that the only thing you meant by controversial statements? Interesting. So how many of you think that a statement like, I don't know, murder is wrong can be understood by... Raise your hands. Yeah, let's see hands. How many of you think that a computer could not understand the statement, murder is wrong? Okay, so it sounds like you're in the minority. Why do you think that? Not to put you on the spot.
Well, just because, like, minority is one, so very, or not minority, okay. Anyway, the statement is just very direct, and you could program a mind or even just, like, a technological mind to think that there's one, like, extreme way. It's not like a weird answer. It's like, it's bad and good and who's like bad.
Okay, so let's make it harder. Or do you want to talk about harder? Go for it.
The computer only does what you tell it to do, so it doesn't know anything.
Thank you.
It can only tell you whether murder is wrong or right unless you told it it was wrong.
Okay, all right, so let's make it a little fuzzier. So what if the statement is stealing is wrong? How many of you think stealing is wrong? How many of you think stealing is wrong all the time, no matter what? Okay, cool. So at least I think we can agree that that one's slightly more complicated. Is there anyone who thinks that a computer can be programmed to understand the statement stealing is wrong? Same thing? Same argument? Okay, or you just want to be contrary? Okay, well, because I actually agree with you. And in fact, my specialty is what's called social robotics, or social artificial intelligence. My job consists largely of designing computer programs that understand human behavior. So that involves a number of things. It involves being able to sense and understand the world. So how many of you have played with one of these? How many of you have ever seen this before in your life? Okay, someone who's played with one, what is it? A Kinect. What does that mean? Yeah, Xbox 360 Kinect. So it's for playing video games, originally. It is, however, a camera that sees more or less in 3D. So unlike a regular video camera, like the one in the back of the room, this one actually is able to measure distance. And so what we see here on the screen, and I'll invite people to come up and look if you haven't, is actual distances from the center of the camera, actually about right here, more or less, out into the world. So if we could look at the values that make up the brightness of that hideous yellow, we would see numbers that are actually distances in, I think it's meters, out into the world. So one of the big problems that we have in robotics is trying to make systems that can even just sense what's going on. How many of you have seen one of these? They're a little tiny. Anyone? What is it?
Isn't it one of those things you can control the computer by just using your hands?
Yes. Do you know what it's called? So it's called a Leap. They're $75 at Best Buy or something. They're in the back corner. They're kind of cool. And when you come up here, play around and see what happens on the screen. Someone in the front, can you see what's going on? What's going on? It does. It does. That's the science fiction-y effect. Can you tell what the thing is?
It's your hand.
It is my hand. So it's actually a camera that is specialized to detecting hands. So can any of you think of things that you might want to do with something like that? Have any of you seen Minority?
Create an alarm system.
Louder? Sorry.
Create an alarm system.
An alarm system, yes, good. And you're even thinking in the right direction. Almost all work in robotics is funded by the military in the United States. Cool, yes. Security system, yes.
If you, like, this kind of far shot, but if you find, like, you know those robotic hands that do surgery with something on hands?
Yes. Yeah, you could totally do something like that. And people are working on that. Next time be louder. Be really loud. The acoustics in this room are weird. So you need to yell. But she said, could you design a robotic surgery system so that you could use your hands and cut people open through a robot? So what would be hard about that?
Well, first of all, if you don't set up a proper, like, sight system, you're not able to see what you're actually doing.
Okay, yes, that is hard. I think, did you have a hand?
Measuring the force and pressure of the object.
Oh, exactly. What were you going to say?
I was going to say, what if you have a glitch or a power outage?
Those are bad. So I have to imagine, because there are robotic surgery systems even here in town, that they have probably redundancies set up. But if all of those fail, someone's probably going to die. Or humans will actually rush in and pull the robot out, and it'll all be fine. Were there other hands up back here? No? Okay, so I think you nailed it. Figuring out the forces and pressures. There's no feedback with this. So if I'm cutting, I don't know how much pressure to apply, which is an incredibly hard problem in robotic surgery. Where else might it be a hard problem? Say in social robotics. Any guesses? You said it was. I'll start picking. Yeah.
Well, I'm thinking like those robots are very personal abilities, so it's just like automated driving.
Okay.
Like they can't really sense like sarcasm or anger or
No,
like.
thank you. Right. So yes, that is a good point, and we'll talk about that a little bit. What about with sensing pressures and forces? Where in social interactions is that hard or weird or potentially bad for a stupid robot? Shaking hands, right? How many of you have ever shaken someone's hand and they squeeze, and they just squeeze as hard as they can because who knows why, right? So with humans, you just kind of grin and bear it. With a robot though, if a robot shakes your hand as hard as it can, depending on the mechanics of the robot, it breaks things. It breaks you. And so that is a social problem, right? Because sometimes you want a firm handshake and sometimes you don't. And the factors that decide whether or not you do, more often than not, are social. So, that was a nice aside, but do you guys have any questions about either of these things? At this point, they're a little bit dull. They've been out for a while. Does anyone have the Xbox One? You do? Awesome. Have you played with the Kinect, the new Kinect at all?
No.
No? Do you talk to it?
No.
Do any of you talk to your phones or to your...
Yes.
Yes? How many of you talk to your phones and expect a response? Right? Does it work?
A lot of times.
Sometimes, a lot of times. You're all incredibly young, so you probably don't remember really bad speech therapy. But that is something that is incredibly important in robotics. And in fact, actually, how many of you have noticed that in the past year or so, it's gotten much easier to talk to your phones? Right? Do you guys have any guesses why? Really smart people are working on it. Smart people have been working on it for several decades, longer than anyone in this room has been alive, actually. But it turns out there was actually just this one major breakthrough that just happened in 2006 to really make everything significantly better. So we'll talk a little bit about that if you guys want. But I think I'll switch gears and show you some of my videos. So let's start with stealing stuff. No. Okay. So my specialty is what's called intent recognition. So it's the most basic problem in social interaction. It's all about watching other people and making guesses about what they're going to do next. So lots of you are drinking stuff. So you have a bottle of water and it's not empty, right? So you know it's not empty. How do you know it's not empty? Okay, so it has weight to it. That's a really good answer. You can see that there's water in it. Have you been drinking from that? Yes. Could you go ahead and drink from it right now? Everyone watch her. Yes. Okay. Yes.
You can tell by the angle of which she looks from. For example, like you know she's out as soon as you drink fully burnt.
Yes, so you can, and that's a really good signal. How many of you, as she was reaching for the bottle of water and as she was tipping it back, were confident that she was going to actually drink from it? How do you know? Because you told her to. I tell lots of people to do lots of things and they don't. I teach. But seriously, how do you know? I mean, there are any number of things that she could have done with that bottle of water. When I'm holding this now cold Americano, there are any number of things I could do with this Americano. How do you know that I'm probably either going to set it down or drink it?
You know, like, you're practically drinking this, you're drinking.
Okay, but what does that mean?
It means if you pick something up that has a beverage in it, then you're really going to drink it, there's nothing else to do this with.
Oh, yes, exactly. Okay, did everyone hear that?
No.
Did you say it louder? Really loud.
You've been conditioned to think so.
Excellent. So we'll come back to that in just a second.
Like it would be out of the ordinary to do anything else with it?
Outstanding. Yes. So, did everyone hear that? It would be out of the ordinary if I were to say, throw it at you. That would be weird, right? Uncomfortable and weird. Were there other hands? And what did you say? I think you were being snarky, but you're right on this. Obnoxious. Yeah. No, what did you say though? Because it was really good.
It's a practical piece of a beverage that you're not just drinking.
Oh, I don't think you were making the obnoxious comment then. Is it something over here? Something
That's
that's...
what I was trying to tell you.
Okay.
Trying to be obnoxious.
Okay, bummer. Well, someone said something about you're a part of the system or something like that.
To be
Okay, yes, yeah, so that's exactly right. So we know what people are going to do because we've been conditioned by our experiences and by social interactions to expect certain things out of people. And it would be really weird if people didn't act in ways in which they've been conditioned. So another way of saying that is that the probability of doing the socially right thing is very high, and the probability of doing the socially weird thing is very low. So this video shows two robots. So in this pane, you're going to see what a robot sees as it's driving down the hall. And then in the top left corner, you're going to see a robot's view as it's sitting in the back of a room. And the robot has been trained to understand a couple of different behaviors. So we taught it how to follow people. We taught it what stealing means, what meeting someone means, what dropping a bag off means, and what passing by means. So those are behaviors that we taught it to understand. And you're going to see, I think Alreza walks into the office, sets a bag down, and starts to work. Someone's going to steal the bag, the robot's going to figure that out, and it's going to tell the control robot to follow the culprit. So the robot is tracking agent number 0, 4.7 meters away. Agent number 2, which is a bag, is 5.7 meters away. This robot is just wandering along. Those are probabilities of various behaviors. So the robot actually saw, in that instant, that person number 1 is stealing the bag. With a 79% chance, 80% chance. So it sends a message to the robot in the hall and says, follow the bad guy. So this is actually a map of my building. And the robot is following the bad guy. Any guesses who wins this time? The bad guy wins. The bad guy wins because even though it's a little bit hard to see, this is a short robot on wheels and it has no arms. So if you're the bad guy, how do you get away? What do you do? Quick. It's 50 pounds, so you can't just kick it. What?
Go through a door.
Yeah, you go down the stairs. And close the door. Okay, did you have a hand up? Yeah, okay. So that was a really simple example of something that, so could all of you have done what the robots did? Yeah, so if you know that Alreza owns the bag and that no one else is supposed to take it, could you watch as someone steals it and say, hey, that's not cool? Yes? And could you follow the bad guy? I would be willing to bet that all of you, even though you're still kind of quiet, probably could without much difficulty. But there are several things here that are really, really hard for a robot. So for instance, right now we put a box around the human and we say, okay, that's person number 0. We don't know their name and it's a robot, so numbers work. Person number 0, and they are 4.6 meters away. How many of you could guesstimate 4.6 meters? Really? I couldn't. I totally couldn't. You know, 4-ish meters-ish. So that's actually something robots can do reasonably well. Any guesses how? Yeah.
You take something that's just as far away as the scale.
That's a good one. So you take something whose distance you know, look at how big it is, and then you do some math, some trig. Yes.
They could be pre-programmed with like the scale of the room, and then you can guess.
Yep. So you can cheat and tell them the answer, which is something that people do, especially if it's a stationary camera.
They can triangulate with multiple cameras.
You could triangulate with multiple cameras. Yes, you can. That's really hard, but yes, you can. Are there any other guesses? Oh, really good. Okay, what kind of signal? Let's run with that. Sonar and laser. So, yes, those are exactly right. In this case, actually, that number comes from a laser range scanner. So it's actually a coffee pot-shaped box that shoots a laser, sees how things bounce back, and then is actually able to measure distances 100 times a second using time of flight. But we also use sonar. So that's actually why robots are really good at that sort of thing. How does the robot know what a person looks like? Yeah. Movement, okay. Expand.
Height definition.
Okay, those are both good signals. If it moves at all.
Things that all without like
Okay. How do you detect when something is acting upon something else? That's kind of philosophical, but. What did you say?
Leg.
What's a leg?
Dang, this is getting deep.
Right?
It's matter that
Matter.
the two
Two
pegs.
two
that
pegs.
have to be a good location.
Cheers.
Is that a leg? Are those legs?
It's a different type of leg.
It's a different type of leg. Okay. How about this? Yes.
What about sensing the heat that's coming off of
I
Sensing the heat.
Heat, yes, that's a really good one. So we don't actually use thermal cameras, but some people do. How would you detect a human? Humans are hot?
They are temperature.
What about other things? Are other things hot? Okay, yes.
They're like one of the only things that moves on 2 feet.
What does that mean?
Like there's one.
That's what I would say, but
You're both absolutely correct, but it's harder than that. Because you can keep asking why. Okay.
I would say like growth as well.
Just thermal. But yes, yeah.
That software you have there to detect the hands,
Yeah.
well, they could use that by like ranging like just approximate areas where joints are, and you can create a skeleton without hands.
Yes, that is exactly what people do actually in practice. So that's cool. So this whole area of detecting people from video is something that people have dedicated their entire lives to. So back in, I think, the 60s, a couple of professors at MIT said to their grad students, figure out this whole camera thing and get back to us at the end of the summer. And because people really thought that you would be able to just figure out how vision works in 3 months. And so they gave it as a summer homework assignment. half a century later, we're still not really any closer to understanding how this actually works. How people see other people, recognize other humans, and do stuff with that information. Everything that everyone said is a way that someone has used to try to identify people and to track them in space and time. So you're very smart. But it's still a very hard problem. If we skip forward a little bit. Okay, so this is a map of my building. How do you make something like that? What? Yes? Other thoughts?
I had a different question about the recognizing humans.
Okay.
So if you don't use thermal imaging, then what if it's a dark room? Then does that just kind of mess the whole thing up, right? Like the same colors. Like if somebody was wearing a black shirt and then they're by a black wall, and they blend in with it.
Yep.
Does that mess up the whole process?
Yes, it does. So it actually depends on the type of camera. So a camera like this, obviously color doesn't really matter because it's sensing depth. But for a regular RGB camera, yes. And in fact, there were some very early experiments. I don't think that I have the videos for them, where I had to wear these horrible Hawaiian shirts because I wear dark clothing and I blend into the backgrounds in most of the buildings on campus. And so yes, it can be a huge problem, unintentionally or intentionally. So yeah, good observation. So what did you say about mapping? Yes, so you can start with a map already, and then you can localize relative to the map. How do you think we built this map? What? Yes, so we took a lot of pictures. So if you actually look really closely, this is what the camera sees, and we stitched them all together. But this is actually a pixel-perfect map of the engineering building. So I can tell you that, you know, a pixel is like 0.2 meters-ish. So it's actual distances. How do you get those?
Measuring.
Yes. So you keep going. With louder, someone? Yes. Yes, but that sounds really hard. I'm a robot, I'm stupid. I've got wheels, I've got a laser, I've got sonar, I've got a camera. What do I do? What do I measure with? What? So yes, actually you could do that. There are some undergraduates who are doing that right now in this building to get better maps. So that's a good answer. This one was actually built with lasers. This is one of the few talks, I think, where the answer to at least 10% of the questions will be use lasers. So are there any questions about this video or about what's going on with social robotics? Yeah.
What is the exact purpose of having a social robot?
That's a really good question. What would you use a social robot for?
So I use it as a friend.
Okay, so that's actually something that people have thought about. So people want to build robot companions, which is not actually that outrageous. One area where it's particularly applicable is with elderly populations. So I don't know if you follow demographic trends in East Asia, but Japan has a huge demographic problem right now where people are getting old much faster than people are being born. And so you've got this exploding aging population. And a serious problem is how do you take care of all of these elderly people? And one thing they're trying is robots. So yeah, actually robot companions is a very good answer. Yes?
There actually is a video game being produced right now that uses this type of social stuff, and it's supposed to be able to have the user talk to them, and you can use sarcasm, anything you like, with speech, and it will respond using its array of options.
Right.
It will respond underneath as well.
Making more engaging video games is an application of this technology.
Like you said, now the military comes in greatly, like soldiers, and that way people aren't dying, but it's not a great thing.
That's a very, very nice, politically correct way to put it. We want Terminators, guys.
Yes.
The United States Department of Defense wants Terminators. So that's actually not entirely fair. They don't really want Terminators because they don't want machines that can pull the trigger on their own. But what they do want are machines that can analyze a situation and be able to, for example, engage in humanitarian operations. That was actually sort of the underlying motivation for this work, was how do you build a system that can deploy to an area that's been hit with a disaster, and then do disaster response in a way that is effective.
What about to reach the singularity?
And then there are some people who are just philosophically all for sentient machines. So, so some people do it for philosophical reasons. Some people do it because they want robot companions. The military is very interested in this technology for all the obvious reasons. And video games. Video games are a good answer to why is this happening for a lot of questions. Other reasons? I don't know, I was at a talk in Japan once where a professor, one of the top roboticists in the world, said that the two reasons that anything happens, or that progress happens, are laziness and vanity. So laziness, we want machines that will work for us, and vanity, we want to make machines that are more like us. So I have a few other examples of this sort of behavior. In this case, the thing that's kind of neat about this is I actually built a robot that read Wikipedia, the whole thing. And we trained it to use Wikipedia to understand human behavior. I got in a lot of trouble for letting a trash can fire in my lab. But the robot was actually able to parse sentences in English and then use that knowledge of linguistics to make predictions about human behavior. So in particular, it could tell, for instance, here, when I reach for an extinguisher, I'm probably going to put out the fire. Or when I reach for the snack, I'm probably going to eat it. Actually go with this one. This one's super corny. I'm so sorry. But this shows, actually, so it was this was the robot that was actually doing the patrolling in the first video. So it has wheels, and then you can actually kind of see the box on top of it is the laser scanner. And then it has a connect to Steve. So in this case, the robots are all going to talk, and it's the same sort of thing, predicting human behavior.
Good morning. How are you doing, robot?
You're activating another idea. Am I not good enough?
No, I think you're wonderful, but I do need to use this one, even though it looks like it might be a little
They sound terrible.
Right, you activating that humanoid.
I need it for the project. I'm terribly sorry, but I should have this up there.
That humanoid. It's so annoying.
I know. It can be. Hopefully it won't be this time.
Howdy, partner.
Well, hello.
I'm Billy Jonesy. Pleased to make your acquaintance.
Really?
it looks kind of weird because this is actually a connect. This is what the connect sees. So it's actually segmenting out the person from the background, or the person in the object from the background. And
Robots with wheels are so much fun to robot.
because of the way the connect works, everything shimmers.
Hold on. Let me work on this. No, actually. Why don't you help me out with this?
You can see approximately how fast and how well they run.
I'll take that battery if you don't mind.
I don't mind, even a little bit. Thank you very much.
I guess it's what this is. Yes, it's a little fuzzy. What? Oh, what? Yes, power cable. So one of the biggest problems in robotics is actually not a robotics problem, it's having enough battery life. So any guesses how long a robot like that can drive around on its own? It's longer than 10 minutes. An hour. Yeah, you get about an hour with those robots. So one last video of robots to show you. So the other type of robot that I work with is a humanoid. So what's a humanoid robot? Does anyone know? Has human features. What kind of human features? Limbs, arms and legs, yes. So this is our robot Marie. Those are...
Sure, I'll take the floor.
So this is another reason you might want socially capable robots. Servants,
Here you
without the
go.
guilt.
Thanks, Marie.
That food you are eating looks yummy.
Does it? It smells like cardboard.
Do you have a glass for your drink?
Yes, I have a glass.
So here you can see what we did before we had to connect. We have to actually go backwards from a 2D image to a 3D estimate of what the world looks like. That is as hard as it sounds.
Be careful.
It's actually maybe
You
harder.
do not want to spill on your table.
Yes, thank you, Marie.
Setup. Next cavities.
I am aware of this.
So she's actually choosing her responses based on the probabilities that she's testing. We couldn't use real food because we had to do a lot of things. So that is impact our food.
Do you want me to throw away the plate?
Sure, Marie.
Pay particular attention to the way that Marie walks. It wasn't at the time. That was a huge relief. I think we finished shooting that at 4 in the morning. Why was it funny? No. Slow? What? Just really slow. Obnoxiously slow, right? Why else was it funny? Yeah.
Because the responses didn't make a lot of sense on the time.
Yeah, so some of the time the responses were a little off.
I just saved it so it gets better.
Yeah. Yes. Actually, I think at that point I was writing dialogue that was supposed to be obnoxious. Why else was it funny? The way she walked. So what about it? The swaying was really weird, right? Okay. Anything else? Really slow. Yeah.
The time it took for it to start right action, she stopped it and then she started with action.
Yes.
And the way she dropped the plate.
The way she dropped the plate. Yes. All of the motions were wrong. They were terribly, hopelessly wrong. Nothing that the robot did looked at all like a human. And that was actually, that was the very limit of what that robot can do. So not mechanically, but in terms of control. So if you watch the video carefully, you can see that the robot doesn't walk the way that people walk. How many of you have really closely watched people walk before? That's awesome. Cool. Okay, so you know that walking is kind of like falling. It's a very crazy dynamic thing. The robot, though, walks by first putting all of its weight on one foot, moving the other foot, and then transferring the weight. And it repeats that. The reason it was wobbling is because you can't do that kind of walking cycle any faster without losing stability. So I actually had to set the walking speed, essentially, and I found the fastest it could walk without losing stability. And so the wobbling, it doesn't wobble if you slow it down to the recommended speed, but if you're living fast and dangerously like we were, you run the risk of the robot tipping over. Any guesses how much that robot cost? A lot is a really good answer. Many thousands. So it's about a $20,000 robot. So it's 4 in the morning, your $20,000 robot is wobbling, and occasionally will just throw itself off the table. I think I was actually standing just off camera, ready to jump, dive, and catch it in case anything went wrong. Which brings up another thing about robotics that is very challenging, that we think of as basic. Do you have a question? Okay. Yeah, so it's insanely expensive still, though that's changing. Things are getting much, much cheaper. But walking and motion and being able to drop an object, things like that that we take for granted are still extraordinarily difficult. And probably will be for some time. The reason that you haven't seen a robot that can run a marathon is because it just doesn't exist yet. The batteries don't exist, the mechanical doesn't quite exist, but the programs, the software, the artificial intelligence doesn't exist yet. But we are working on it. So before I transition to data science, does anyone have any questions about robotics? Or, yes?
Oh, okay, so I have two.
Okay.
So the first one is, okay, I see this thing where there's a bunch of monitors hooked up to ones. It sends like thingy to another robot, and what they do is they move together, like a human moves, the robot moves in a way that the human moves.
Yes.
Couldn't they just like bring down that data and make the robot move like that? Because it stays stable, or no?
Yes, so you totally can. There are some challenges. One of them is that my motion is different from a robot's motion because I am mechanically different from a robot. And so not only do you translate the motions directly, but you have to take that into account. So Marie has, I think, 24 degrees of freedom. I have many, many more. And so you have to find a way to filter out the differences between my motion and the robot's. And we actually have done that with the Kinect. And it works reasonably well. But what happens when the robot goes outside and needs to step down the stairs, and I haven't shown it how to step down those exact stairs. It becomes challenging. And so actually, you have to teach it, you have to make the robot learn, essentially. And it has to be able to generalize from its experiences to new situations, which is really the core of what makes it so hard. Is you want learning to be flexible, but that takes a ton of time and a lot of resources. But yeah, people are working on that. And essentially the ways that we're making walking better come down to coming up with more clever ways to teach machines. What was your other one?
Okay, so you know how like only like part of the brain is actually active and like actually does stuff for us that we know about?
Sure, let's run with it.
Okay, anyway, so I was just thinking, if you were to like, because I know everything's kind of big and funky when it gets like really like complicated, but if you were to just make this really big, massive, hulking like figure, would you like incorporate enough like facial like recognition and like features and stuff like that to make a robot that would actually like seem like a human covered in like
Probably not yet. Social intelligence. So right now, the state of the art is that if we could make a robot act like a 4-year-old, well, that's decades in the future. A 4-year-old behaving robot, decades. And that's at the rate that we've been going. Maybe there will be some magical advance or something that will just happen. You know, someone will come up with the theory of relativity, but for robots, and change the field completely. Seems very unlikely though, given the progress that we've seen thus far. So the personality won't really be there. There are areas that we're just starting to really explore with computer science. Emotion, for example. There's an area called affective robotics, affect, emotion. And that's something that, I think only 1 or 2 people in the world are currently working on. But emotion is such an important part of intelligence that if we want machines that can act like people, we're going to need a lot more work done there. But you can treat people for about 5 or 10 minutes right now. You can make someone think that they're talking to a human when in fact they're talking to a computer for maybe 5 or 10 minutes, which is pretty impressive, really. Because we're really good at recognizing when the thing that we're looking at isn't actually a human.
Instead of trying to teach every robot what, like stairs, for instance, like walking down every stair, why don't you have like a big server or a big database and you wirelessly transmit the data to the robot? Ask it. Like it's like, oh, here's some stairs. Where's the data for how to walk down the stairs?
What's the fastest you can send a message from Reno to Paris?
Very quickly.
Any way. An email. How long does it take an email to get from Reno to Paris?
Not very long.
How long? Do you know? Does anyone know? Does anyone have any guesses? It's a number, it's a, let's go with milliseconds. It's some number of milliseconds. What? It takes about 13 milliseconds to send a single packet of information from here to Paris. The reason that's a problem, so that's actually the fastest possible. That's with the speed of light. Real networks are much, much, much slower. I was testing a network connection to some colleagues in Italy, and it took about 200 milliseconds to send a message from Reno to Italy. Yes? Yeah, so that will help, but the problem is that robots have to be fast. The bare minimum is that a robot has to update its mental state, bless you, 10 times a second. And so within 100 milliseconds, you have to be able to sense the world, send your message to wherever, have it get processed, send the message back, and then translate that into actions. So cloud robotics is something that people are working on, and the solution is basically big databases all over the place. Yeah.
But like nowadays, you can get laptop computers with 2 terabyte hard drives
Yes.
That's an amazing amount of information in such a small space.
Yep.
So, I mean, how much information does it take to put all the possible stair combinations in?
Lots. What, more than 2 terabytes, just for calculation.
Okay, why don't you have like a program that can calculate all of the
Yes, and it is amazing. So it's a testament to how awesome humans are that we think that that's easy. Because we know what stairs are. I mean, we couldn't probably define stairs, but if we see a set of stairs, we can tell what stairs look like. There's so many variations, though, that trying to pre-compute and store all of them is prohibitive. And even if you could do it with stairs, that's just stairs. What about tables, chairs, people? So it's just, people tried back in the 80s to calculate all the answers in advance, and the videos of the robots are 10 times slower because there's just so much. So, yeah.
So, you can find a way to write a program that would write a program in situations this
It would be less of a problem. So that's actually called the field of machine learning. And people work on it a lot. In fact, all of what I showed you uses machine learning. So we didn't program the robots to understand what, for example, a cup looks like. We showed it lots of examples of cups, and it built a statistical model of a cup. And then when we showed it similar cups, it was able to recognize what a cup looks like. Which sounds immensely trivial, but it's not. Yes?
So going back to her talking, for her, know her responses, did you have to like program all her words into her? Or?
Yeah, so she can generate words. So if you give her a string of words, she will say it in a way that sounds good. What we were doing was we were showing that she was recognizing the correct behaviors by giving her a list of 100 or 200 different things she could say, and then she chose the appropriate thing based on what she assessed to be the current state of the world. There are people working on generating English from scratch. That's an area called computational linguistics, so natural language processing. It's really awesome. It's not super far along though. So that's another area that you can get into. Yes.
So for the like cloud robotics, if you were to have like 3 or 4 data stations with all of the data, and then if you were to have like multiple robots, but then you have, like she said, local hubs, but like the local hubs would get things that were more often used by the robots in that area, get into the local hubs, and then it'd be quicker.
That is what it's going to look like. I'm pretty sure, how many of you have seen articles about Google buying all the robotics companies? Google's buying all the robotics companies. I think that's what they're doing. I'm almost certain. Other questions about robotics?
So is that what it's going to turn out to be? Is Google turning the robotics age that
Probably. So it looks like actually, I know we can talk about practical things before we get the last video. Yeah, Google's buying all the robotics companies that they can. They're spending outrageous amounts of money on robotics and artificial intelligence. In fact, they have since the beginning. Google is basically an artificial intelligence company. So they're going to drive a lot of it. Facebook is now responding. You know, Facebook and Google are terrified of each other, right? Are you guys aware of that? Absolutely terrified. Because eventually they want the same thing. They want to take over the world. And only one of them can. So Facebook just created an artificial intelligence lab. And they've been trying to hire everyone they can to work on AI for Facebook. And they will compete with each other to get the best talent and to do the coolest stuff. Eventually, they both want Skynet. They just want to own it. Which kind of brings me to the last sort of practical thing, which is money. So the cool thing about computer science, if you want to go into the private sector, is that people just throw money at you. My roommate just got a job at Amazon writing code for making recommendations about shipping. Any guesses what a job like that pays? Yes, more than you would think. Any guesses? So her starting package was just shy of $200,000. Yeah, so she gets stock, they pay for her to move up to Seattle, they give her $100,000-ish a year to start. So they just throw money at you, and that's Amazon. Amazon has a reputation for being cheap. Another guy who's graduating from the CS department in May got a job at Google. Any guesses what a job at Google doing computational neuroscience looks like? No, not to start. No one pays half a million to start. Starting salary, I think, is, if you include bonuses, about $300,000. Does anyone know what the top graduate of Harvard Law School makes going to Wachtell, Lipton, Rosen-Katz, which is the top financial law firm in New York? $165,000. So, you know, you can either be the top graduate at Harvard Law School and make, you know, $150-ish, or, you know, get your master's in CS here, go to Amazon, make 2, or Google and make 3, starting. There are mid-level engineers at Google who make a couple million a year. It's kind of cool. Have I persuaded anyone to become a... Yes?
So I want to know, if you can go out and make $300,000 a year, what do you do a year?
That is a question that I ask myself sometimes. So I actually am not just on the faculty, I also have a couple of startups. So yes, that is the right one. And actually, it's kind of a gamble. You can try to start your own company and make $1 bazillion. And then if it fails, you go get one of those jobs anyway. So, I mean, it's not like there's really any downside risk to trying crazy things. So, I like risk. I live dangerously. But that is a fair question. I had to say no to Google. It was hard. What? That's right.
Do you like teaching?
I do actually like teaching. Teaching is fun. So do we have time for a 5-minute video?
Absolutely.
Okay, cool. So robotics is what I spent my grad school years doing. These days I do something called data science. Has anyone heard of data science? So people have non-ironically called it the sexiest job of the 21st century. It's basically a combination of statistics and computer science. It's all about making predictions about the world. And so for this video, Hillary Mason she was a computer science professor, and then she worked for a company called Bitly. Has anyone heard of Bitly? They shorten URLs, which sounds trivial and stupid, but is actually extraordinarily hard. And then she got pulled into the venture capital world, so she does finance now. But she's going to talk about the optimal cheeseburger.
Thanks, Chikva. Well, so if you live in a city, you have a lot of restaurants that you can choose from, but there's a problem in that the rate of change in those restaurants and how quickly they turn over exceeds your rate of food consumption capacity. They change too quickly. So I love two things. I love data and I love cheeseburgers. And I started thinking about how data could be used to help me find the best cheeseburgers before they were gone forever. And I'm not alone in this. So this is the United States in beef space. That is McDonald's in black and Burger King in red, and Sonic is the little teasing bit of teal that is never actually anywhere nearby. And as we saw in our healthcare costs, it's not just food, right? So geeks love cheeseburgers. This is my favorite chromium bug of all time. It is a fundamental flaw in the iconography of the cheeseburger. The cheese appears below the cutlet in the icon. This is serious. So my project actually begins here in New York in the West Village, and I was walking around one day and I saw a new restaurant, and it was intensely boring. And it was boring because I thought it had to be the median West Village restaurant. It only had the same dishes as every other restaurant. So I started thinking, can I prove that? What data can I get? So I went to the internet and I borrowed a lot of data from our favorite menu and food rating sites. And I got together all of the menus for non-fast food restaurants in Manhattan. And so the first thing you do when you look at a new data set is you look for something you know, right? So this is Chinese food in New York City, and there it is, I found Chinatown. So the next one, I'll see if anyone can guess what this is. More restaurants than Chinese restaurants. Right, so there are two dense clusters of Italian food in Manhattan. One of them is Little Italy, one of them is the Nouveau Italian West Village place you take your mom when she comes to visit. And this last one, of course, is most relevant for those of us here today because it's near where we are geographically. This is the secret Hell's Kitchen Thai enclave. For some reason, that's the highest density of Thai food in Manhattan. Right, so let's get back to cheeseburgers. There are 5,247 cheeseburgers, and that's not counting all permutations and combinations. That is the base cheeseburger at every restaurant that offers a cheeseburger in Manhattan. So which one do we go get? There's a little bit of a decision paralysis here. So we need a little bit more data, not just where the cheeseburgers are, and we need to come up with an algorithm for selecting one. So to start, we need that definition of optimality of the cheeseburger. And if you read the literature, there's a lot of thinking around the meat to bun ratio. We already know the cheese goes above the cutlet. Unfortunately, some of this data is a little bit hard to come by. So I settled on an algorithm that had three main input factors. Taking your current location as the first one, how far are you willing to go to get a cheeseburger? I know for some of this is very far, but you can query Dark Skies API and see how far you can go, given the current weather conditions, to get your cheeseburger. Right, so that's factor one. Factor two is price. You do not want to get ripped off. So this is the histogram of all cheeseburger prices. You want to be in that middle range between $8 and $16, and do not get fooled by the children's menu at the fancy steakhouses. The third thing is quality, and so I approximated that by searching Foursquare's Explore API for tips that said specifically get the cheeseburger, cheeseburger A+, cheeseburger, 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 cheeseburger. And so, to validate the algorithm, you actually have to go out and try them. And I've been inflicting this on my friends and coworkers for the last few weeks, so sorry guys. But it seems to work pretty well. So if you follow this model of proximity, price, quality as decided by the community, you will end up very happy. Depending on your starting point, you may end up in a very different place, and that's totally okay. So there are two morals to this story. One is that the data is out there, and whatever frivolous and ridiculous question you're obsessed with, you can find something that will let you look at it in a new and exciting way. And it doesn't have to be very hard. You can think of that data as a framework where you can look at a familiar place in a new way and learn something interesting no matter what you happen to be obsessing over at the time and how serious or frivolous it may be. The second moral is just that everybody loves cheeseburgers. Thank you.
So the point of that is actually, I'm going to, let's skip the cheeseburger part, emphasize data is everywhere. So you're young enough that maybe you don't know this, but there was a time when it was really hard to get data about anything at all. The fact that she can get data about the quality of cheeseburgers in Manhattan and can tell you that there are 5,200 and whatever cheeseburgers that you can get is mind-blowing, and we are just beginning to understand the implications of that. So another partial answer to your question, why am I doing what I'm doing, is that there are extraordinary opportunities for people who are interested in working with data, who have the ability to program computers and understand statistics. Really, in the very, very near future, almost everything is going to be data-driven. I have a friend who's an astrophysicist at the University of Chicago, and she basically writes code. That's all she does. She writes code and she does stats. In biology, I'm working with a graduate student who does genomics, and all she does is write code. She writes code and she does statistics. Field after field is turning into code, stats, and then something else. And we are only at the beginning of that. By the time you are looking at graduate school, or even towards the end of your bachelor's, everything is going to be data-driven. It's kind of mind-blowing because it's a completely different way of looking at the world, but everything from political science. How many of you have heard of Nate Silver? Has anyone heard of Nate Silver? he predicted the presidential election down to the state. I think he got all the governor's races correct too. He did it with statistics and with computers. And he did it in 2008 and in 2012. Politics, political science, is becoming an exercise in using statistics and computers. Most of physics at this point is all statistics and computers. How many of you have heard of the Higgs boson? Got discovered. It was a big deal. How many of you heard the 5 sigmas business? So the reason they think it exists is because the probability that that they would see what they did is so extraordinarily small without the explanation of the Higgs that it couldn't be anything else. So they use statistics and computers to do it. They generate outrageous amounts of data that they have to process, and so they're writing code and doing stats. Biology is that way. I'm sure chemistry is, though I don't know anything about chemistry at all. Basically everything is turning into something to do with data. And so if you go into computer science, you get a front row seat to the way that our civilization is changing in the 21st century, which is mind-blowing and cool. So are there other questions? Anything at all? So I now have no idea what's happening. What is the